Hello students, we'll have a little video on the 4 counting rules we've discussed in course and in the course package. The first counting rule is multiplication rule. Typical question deals with trying to determine how many outcomes exist in various events. Now these counting rules, first section of probability in this course, deals with trying to determine the number of outcomes, so that later on, once we know the number of outcomes, we can then determine various probabilities of certain events occurring. So let's make sure I got my pencil in blue. First counting rule is a multiplication rule, as I said. We want to determine how many outcomes exist with rolling 2 dice, for example, and let's just go with 2 coins. So our dice represented in those 2 spots, and our coins represented in those 2 spots. Each dice has 6 outcomes. 6-sided dice, 1 through 6, multiplication rule. Second dice also has 6. Our first coin has 2 outcomes, heads or tail, and our second coin has 2 outcomes. So 6 times 6 times 2 times 2 will give us 144 different outcomes. If the question we're dealing with, say, 3 dice, there's our 3 dice represented by those lines. We have 6 outcomes in our first dice or die, 6 outcomes in the second, and 6 in the third. That gives us 216 total possible outcomes that could exist in those, in the combination of rolling 3 dice. Let's erase that to move on. The second counting rule is one that deals really well with locker combinations, the total number of passwords possible, and with numbers or with letters, with or without repeats allowed. So let's look at a typical, we'll go with a 4-digit locker combination. So this could be like a bicycle lock, a lock on your your computer, a password, as long as it's 4 digits. And we are going to allow repeats, so that you could have, and you shouldn't, but you could have a locker combination 1111. So the 4-digit locker combination is going to be represented by these 4 spots. And I find this is the best way to kind of envision what the total number of outcomes would be, is to actually, draw it out like I am. We know that because we're dealing with digits, we have a choice between 10 digits, 0 through 9, 10 in the second, 10 in the third, and 10 in the fourth. So there could be a total of 10,000 different locker combinations that could be used. Now if the question were no repeats, 4-digit locker combination, there's our 4 digits. We would have 10 options in the first choice, ten options in the first choice, 9 in the second, 8, and then 7 in the last spot. So we can't have repeats, so we could choose 10 values, 10 digits in the first, but we can't choose the same in the second, so left with 9. This gives us a total of 5,040. So let's move on. The next counting rule is one that deals with permutations. This differs slightly from the last one we'll talk about, combinations. Permutations is the key difference is that order is important. So in the question, there has to be something specified about or specific about the rank, order, or preference of the items being chosen. So a classic example, say we have 4 students and we need to select 2 of them to represent president and vice president in a class. So we have 4 students. 2 of them are going to be chosen to be vice president or president or vice president. So we're going to name the students A, B, C, and D, and we're going to actually list out all the possibilities. So let's change this to this color. So first possibility is student A and student B. First item listed, A is the president, B is the vice president. Student A could also be with student C. Student A could be with student D. A in those 3 is the president with B, C, or D as the vice president. B could also be the president with A as the vice president. Note that in the first option we had A and B, now we have B and A. Because order is important, these 2 are separate outcomes. Student B could be the president with student C, and likewise with B and D. Filling this out, we're going to run into these options. Student D is the president with student A, B, or C as the vice president. If we add those all up, you note that we have 12 outcomes. Now if we turn to the actual permutation formula, it will look like, just have to delete that, it will look like this. NPR with n factorial over n minus r factorial. Let's make that a nicer n. N is a total number of things that we get to choose from. We're choosing 4 students. R represents the number we are choosing. So 4 minus 2. And can't forget the factorial up there. 4 factorial is 4 times 3 times 2 equals 24. 4 minus 2 is 2. 2 factorial is 2. And that gives us 12. Now on most calculators, you will have an NPR function. It might be close to the subtraction sign or the addition sign. Knowing where that function is will save you some time on the quiz and on the exam. To enter the values in order to get the right answer, I believe most calculators want you to enter 4 as an N number, and then this NPR button, and then 2. And then you equal sign, and then you shall get the answer of 12. So you can do it with the formula, you can do it with the function or the tool in your calculator. So that's permutation. Order is important. Let's skip ahead to the next one, which is combinations. The difference between combinations and permutation is that order is not important. Order is not important. So, classic example, similar to the permutation example, we have 4 students and we are selecting 2 of them to go on a field trip or for a special project. Nothing in the question is going to specify anything about rank, order, or preference. So let's let's list out the possibilities. We have 4 students. We're going to name them A, B, C, and D. Let's change this to blue. So we have student A and B being chosen. A and C could be chosen. A and D could also be chosen. B could be chosen with A. However, because order is not important, that is the same as A and B. It does not matter if you've chosen first or if you've chosen second. So then we continue, B and C, B and D, and our last item would be C and D, because all possibilities have been counted for. So here we can see that we have 6 outcomes under a combination when order is not important. So as I said, the main difference between permutation and combination is something in the question has to specify rank, order, or preference. So let's continue this to see how this would show using the formula. Let's erase this for now. So a combination formula, we have NCR. The formula looks very similar to the permutation. The only difference is we have this extra R factorial. So in our example of choosing 2 students from 4, we're going to have 4 factorial there. We'll have 2 factorial and then 4 minus 2 factorial. So left with 24 being 4 factorial. Then we have 2 times 2. So 24 divided by 4 gives us 6. Most calculators, if you have NPR, you're going to have NCR as well. It's going to be entered the same way. You're going to enter 4, then you'll touch that button NCR, and then 2. And then you will get an answer of 6. If you can't find the NPR or NCR buttons on your calculator, send me an email. Just tell me what kind of calculator you have, and I should be able to help you find where those buttons or functions exist.